So, welcome to everyone. So, today I'm going to take a topic of and the subject of payment engineering. So, it will contain 5 units. The unit one that is uh, that's contained with types of payment and stress distribution on layered system. What are the topics we are covering? That means so. First of all, introduction. What is payment? And next one is payment as layered section. In the topic we are seeing about what are the layered structure in rigid payment as well as flexible payments, and what are the types of payment they are using rigid and also flexible. And the next topic is resilient models. And another topic is stress and deflection in payment under repeated loading. In the topic is we are seeing about the uh, stress and deflection in various, that is rigid payment, flexible payment. So these are the topics which covered by the stress and deflection payment. The first one is we are going to see about resilient models. Resilient models is a fundamental material property used to characterize unbound pavement materials. It is a measure of material stiffness and provide a mean to analyze stiffness of materials under different conditions such as moisture, density, and stress level. And also, it is also a record input parameter to a mechanical empirical payment design method, and also to determine through laboratory tests by measuring stiffness of a cylinder specimen, which is subjected to a cyclic axial load. In that formula, so the resilient models that is equal to sigma divided by epsilon r, where the sigma is a deviated stress, the epsilon r is a recoverable elastic strain. And what are the application of resilient models? The resilient models test provides a means of characterizing pavement construction materials, including surface, base, and sub-base materials under a variety of temperatures and stress states that simulate the condition in a pavement subject to moving wheel loads. The next one is we are having more number of tests. The test is provides an excellent means for comparing the behavior of pavement construction materials under a variety of condition. Example: moisture, density, gradation, and stress states, etc. And these are the some diagram about the deviated stress. So it will contain the total elastic strain and also elastic strain and as well as plastic strain. If you are testing some rigid flexible payment means it will contain sigma 1 is a major stress and sigma 3 is a confining stress. So finally, the resilient models that is equal to uh, sigma d, that is deviated stress divided by epsilon r. Next one is a stress distribution on the layered system. So in that layered system, we are having a lot of layers in a flexible payment. The first one is subbase. So it will contain below 500 mm to the any layered system. After that, we are using subbase system, that is granular material, and also we are providing a base course, that is granular material. The final one is wearing course, that is bituminous or cement or concrete, based on the types of pavement. And also, if you are going to some pavement structure means the vehicle weight will act on the load, that is wheel load. So if you are acting wheel load, that means uh, com- compressive stress, tensile stress, and also Kong of stress distributions. So these are the stress and deflection in rigid pavement. Stress and a deflection due to the, that is the lot of more deflection due to stress and deflection due to curling. So during the day, when the temperature on the top of the slab is greater than the at the bottom of it, the top of the slab tends to expand with respect to neutral axis, while the bottom tends to contract. However, the weight of the slab restrains it from expansion and contraction. Thus, the compressive stress are induced at the top of the top and a tensile stress at the bottom of the slab. So the picture shows that the first picture, that is A picture, shows that the downward curling of the pavement layer, and next picture shows that upward curling of the layer. The next one is the stress and reflection due to loading. There are three types of method can be used to determine the stress and reflection in rigid pavement. The closed form formulas method, the influence chart method, and the finite element method. In this lecture, we will focus on only first method, which is developed by Western Guard, and the methods of determination of stresses and reflection in rigid bonding. So final one is the corner loading. Using the three critical positions, we are considering there are edge loading, interior loading, and the corner. So we already see about the unit one, that is types of payment. In that unit one, we are seeing about we seen the topic of resilient models, application of resilient models, and deviated stress, and its stress distribution on the layered system. So we will see about the next video on the another topic. Thank you.